All right, so we are quickly going to try and construct a network on the fly, and hopefully it will illustrate a few of the concepts that well, for those who actually watch the videos, it would illustrate some of those concepts. And for those who are to watch the videos, then it will kind of give some context in terms of what is happening. So here we have an organization, we call it Network University, and it's a physical building. There are 2 floors, and on floor 1 is the HR department, and on floor 2, we have the payroll department. And what we want to do is to connect up the network so that we're able to communicate within each department. That's one, but also we want somebody in HR to be able to communicate with somebody in payroll and vice versa. And as we connect up the network, we'll be talking about some of the elements on the OSI model, particularly layers 1 to 3, which is the physical layer, the data link layer, and the network layer. So we'll be talking about those elements. We'll also be talking about a few protocols that might be useful in terms of seeing how things operate. And there are a few commands that we are going to cover. Please bear in mind that we are using Cisco Packet Tracer as the tool for our simulation. And being that it is Cisco's software, it means that these devices that we're looking at, like the switches and the routers, are modeled after Cisco's devices. So the commands that we're using to interact with these devices may be slightly different from other things that you will be looking at when you're working with other devices. It can be a little bit different. But what we're focusing on are concepts. All right, so let's start out with the physical layer. So we want to connect these devices. And we're going to connect these devices by going through a switch. And the first question, therefore, that I want to ask is, does anybody know what a switch is? And if you do, please feel free to share. What is a switch?
Um, well, my understanding of a switch, sir, is like it is a hub for multiple different Ethernet ports and so on. So it allows rather than you having just access to like 1 or 2 Ethernet ports, you'd have like access to like probably 10 or 20. You usually use it in like a local area network or some other stuff, but it's usually local, wired.
So I said it is wired and it have ports.
Yes.
Right, Russell? Okay.
Yeah.
All right. I get that. Go ahead, Steven. I'm seeing your hand.
Yeah, so in addition to what my classmate just said, it also helps to direct traffic on the network. So it helps data to be transmitted between devices that are connected on the same network.
All right. So it allows communication between devices on the same network. Javon?
Good evening, sir. Just joining, so I kind of missed what was happening earlier. We'll have to review that later on. Just a quick question, sir. In regards to last week, Wednesday, I think Wednesday is the second session for networking, correct?
I don't know. Everybody timetable can differ.
Oh, okay. I just wanted to ask you a question, but if that's the case, you wouldn't be able to assist them, sir.
All right, cool. All right, so anybody else want to chime in on what they think a switch is? One more. All right. So a switch is a connecting device. And what it does, as was pointed out earlier, is that it allows us to connect multiple devices on a network and facilitate communication between them. Now, I think Sir Russell spoke about a hub, and he was alluding to the fact that a hub is somewhat similar to a switch. So you're going to have two connecting devices, hub and switch. And we no longer use hubs for the most part. You're hardly going to find them in organizations. And the reason, 1 minute. And the reason why we hardly use hubs within organizations is because switches are more efficient. So here's a quick question to your folks. If I send out a message and I want to communicate to one person, and I send out that message and I shout it out, for example, in an auditorium, then is that good or bad? I want to talk to one person. I shout out the message in an auditorium. Is that good or bad?
That would be very bad.
Bad, sir.
Why is it bad?
Because
Might
you
not be.
intended to communicate. You intended to communicate with a single person, but if there's other people in the auditorium, then everybody would be able to hear the message that you wanted to send to one person.
All right, excellent. So there's a term for that in networking. We call it a broadcast. So a broadcast meaning we're sending it to everybody on the network. And that's what a hub does. When you send a message on over the hub, even though it might be destined for one device, it's going to be sent to all the devices which are connected to the hub. So because of security purposes, as well as efficiency purposes, hubs are no longer being used in organizations. So what we are using are switches. And the good thing about a switch is that it provides us with a targeted way of communicating between devices. So we can think of that as actually calling the person on a phone in the auditorium and speaking to that person directly. So if we are clear on that, folks, just type C in the chat just to indicate that you're clear. All right, great. So I'm seeing the responses in the chat. So here we have a switch, and as was mentioned earlier, it has multiple ports. And we want to draw a distinction between physical ports and logical ports. That's going to be a key distinction that we have to make in this course. So whenever we talk about a switch or we talk about a router, those kind of devices, we're talking about physical ports. And these ports, because we're talking about Ethernet standard, RJ45, it therefore means that these ports are going to have some slots. So that's what the port is. It's a slot where we can plug in one of these RJ45 cables. And RJ45 cables are those cables that you'll find in the computer lab and run into the back of the computers. Now, in order to connect these cables to these devices, it means that the devices need to have in a NIC. Can someone tell me what a NIC stands for? NIC, what it stands for?
Network interface card.
Network interface card.
Great. So a NIC is a network interface card. And the purpose of this NIC is to facilitate this connection with the RJ45 cable. So the NIC is what actually have the slots or the ports. So what we now need to do is we need to connect up these machines to the switch. And by virtue of doing that, they should be able to communicate with each other. So we're talking first about the physical layer, where we're talking about the bits being transferred. And the NIC is going to be an integral part of this because the NIC is what is going to actually push the bits over the medium. And remember, we're talking about wired medium now. So the question is, which cable are we going to use to connect these computers to the switch? And we have two cables here, which are copper related because they are based on copper wires. We have the straight through cable and we have the crossover cable. So let's go with the straight through cable first. So I connect it, well, let me backtrack. So I click on the connector and I'm clicking on the device. And remember, we are simulating what you do in the real world. So we are going to plug it into the Ethernet port, which is on the NIC. So I'm using fast Ethernet 0. And then I'm going to plug it onto a port, which is actually on the switch. So when I click on the switch, this switch has 24 fast Ethernet ports. So I'm going to attach it to port 1. So that's the one that you see at the side here. And we connect it up. I'm also going to use a crossover cable. So I'm connecting it to fast Ethernet port. And I'm going to drop that now onto port 2 on the switch. And just by virtue of doing the connection, you should be able to see something happening. So raise your hand and tell me what your observations are. So raise your hand so I can acknowledge you, and then you tell me what your observations are in terms of what you're seeing. Go ahead, Javed.
Sir, I'm assuming that most of the bandwidth is going to the first computer.
When you say most of the bandwidth, what do you mean?
Sir, because the symbols, one look green and one look red, so like naturally in my head that's telling me that the computer number 1 is getting most of the bandwidth or whatever.
Okay, so you're saying that H1 is getting more of the data because it has a greater bandwidth. All right.
Yes, sir.
I think the next person I saw was Javon.
H2 has no connection.
All right, so you're saying that H2 has no connection. Siobhan?
I agree with Joel.
All right, and Dwight?
Okay, I think that it's both computers are connected. That means H1 or computer 1 is sending information and H2 is receiving the information.
All right, I got you. Thanks much. So thanks for your responses, folks. So what is really happening here is that even though H2 is physically connected to the switch, it's an incorrect connection. And because it's an incorrect connection, then it means that if you try to send data, then data is not going to actually reach H2. So H2 will not be able to transmit or receive on the network because we have used the wrong cable. We have used a crossover cable when we should have used a straight through cable. So what is the difference between them? Well, it has to do with the pins on which the devices are going to transmit and the pins on which the devices are going to receive. So this is one of the things I want you to look out for when you watch the video, because I think I kind of go in depth into it. So I want you to watch the videos that you have access to now. And then if you have any challenges, any issues, then we can discuss those in our next class. Suffice it to say, for our demonstration, we can see that H1 connection is green, which means that it's okay. And H2 connection is red, which means that it is not okay. So I'm seeing a hand, Stephen.
So one time I kind of helped. I was watching somebody configure set up, what do you call it? The server. And when they when they do when they cut the wire, I'm almost certain it was a crossover cable that was used, or am I wrong?
All right, that's an interesting question. Let me give you the short answer. It depends, because I'm using a 2950 switch, but there are advanced switches which can auto-detect and do the conversions automatically. So therefore, it means that you don't have to be concerned about whether or not you use a straight through or a crossover cable. It would still work properly, because the switch would automatically detect and do the necessary conversions which are required. Having said that, you are required to know the differences between the crossover cable and the straight through cable, and why you would use one over the other. So we are assuming, well, we are not assuming that these devices that we're using are going to auto-configure to prevent that from happening. So you will need to know specifically which cable to use and why. I hope that answers that. So you can let me know.
Yes, thank you.
All right, cool, no problem. Yes, Javon?
When you say crossover, are you referring to twisted pairs? Is it
Well,
that
both
you're
of them are twisted pairs.
okay?
Yeah. So both the straight through and the crossover are twisted pairs. It's just how we configure the pins. By the way, I am assuming that in your lab, the technologist will allow you to crimp cables, meaning make cables. I'm assuming that that will happen. And when you do that lab, then you get a deeper appreciation of what is happening with the wire configuration and how you set up the cables. Because typically what happens is that you'll make a straight through cable and you'll make a crossover cable so that you can look at the differences between them. And because the twisted pair wires are color coded, then it's kind of easier to see and visualize what is happening at the end of each cable. All right, so thanks for that.
Sir, quick question. By chance, do you have a visual representation?
No, I don't. But if you go back through the recording, then I try my best to visualize it. So let's go
No
back, go
problem,
through the
sir.
recording,
I'll watch
and
it
then
and let you know.
and then you let me know. All right, cool. Go ahead, LK.
Sorry, sir, if you don't mind, because I was just about to ask if it's just the color code, it's just the how the cables are arranged when you're putting them in that connector, the pin. But then you
Yes, it's
answered
how
it.
they are arranged.
Right.
So when it's a straight through, pin 1 on one end of the cable is going to run back to pin 1 on the other end.
Yeah, but for the
But when the
crossover, it
crossover,
has the two
pin 1
different
on one
types.
end is going to run to pin 3 on the other end. So as I said, there's a little graphic thing that I kind of try and construct. So after watching that video, they can let me know if it's clear, all right? So let's continue to roll. So we have connected these devices. We can see that it is green, so everything looks nice. And what we want to do now is to try and communicate. So I'm going to go to machine 1, H1. And I'm going to go to the command prompt. And the first thing that I'm going to do is try and do a ping. But before I do a ping, I have to do maybe like an IP config, so I can see if IP addresses have been assigned. Because if there's no IP addresses, then we can't communicate. So this is something that you need to appreciate. In order for us to communicate on the network, we need to ensure that each device that is going to communicate is assigned an IP address. If that is clear, folks, type I in the chat. So this is critical.
Sir, can you go with us again, please?
All devices need an IP address if they're going to be able to communicate over the network. So I just went to machine H1. I've run the IP config command, and I'm now looking to see whether or not the IP address has been set. And remember, we're using version 4, and we can see that it has not yet been set. So we're going to need to set it. So how do we go about doing that? I'm going to go to this section that says IP configuration, and I'm going to give it an IP address, version 4. Now note at the top here, I have indicated what I want the IP address to look like. So I want it to start with 192.168.20. That is the network. And then for the host, I want it to be host number 1. So that's .1. So notice I put some notations underneath the diagrams. So therefore, for this particular machine, H1, I want the address to be 192.168.20.1. And once I exit out of this little box, then it will give me a subnet mask. And for now, here's what I want you to understand or appreciate. There are 4 numbers that make up an IP address. There are some of those numbers that are going to be used to represent the network ID. And there are some numbers that are going to be used to represent the host. Whenever we look at the subnet mask and we see the value 255, it means that that number that is associated with that 255 is going to form a part of the network ID. So just by looking at what we have here, I know that the network ID is 192 because 255 is under that. That 168 because 255 is under the 168. That 20 because 255 is also under the 20. So that is the network ID or the network address. The other number that is left is where we are going to, is what we are going to use to determine the host number. So how that sound, folks?
Sure.
You could go over that one more time for me, please.
Sure. So when we look at the subnet mask, let me backtrack. Every network needs to have a network ID because that is how we know or we refer to the network. And if we're talking about a single organization, then typically we want the network IDs for each network to be distinct, to be separate. So if I go back to this diagram that we have here, notice that on one side, on floor 1, it is 192.168.20. But on floor 2, it is 192.168.10. So the issue is, How do we know which part of these 4 numbers is used to represent the network ID? And the answer is, we look at the subnet mask. And in this particular case, I am saying that once the subnet mask says 255, then the number that corresponds to that is part of the network ID. So in this subnet mask, we have 3 values that say 255. And if we line them up to the version 4 IP address, we realize that we're talking about the first 3 numbers. So the network address then for the HR department is 192.168.20. Oh, that's all.
Good, sir.
Okay,
All right,
good.
great.
So basically, if you give any other result besides 255, then we have a problem for the IPv4 address.
Well, you would have a problem now because you don't know how to interpret it. But by the time we reach there, you won't have any problem because you know how to interpret it. But for now, we're only going to use 255 to represent the sections which are part of the network address for simplicity. Good? Right, it look like that no good. So
yes, sir. Yeah, we're good.
Let me try something. If I were to give you this, I were to give you this, and I were to say to you, what is the network ID? Then I want you to type in the chat, folks, what the network ID is. So we're talking about these 2 things in red. You have an IP address and you have a subnet mask. And I'm asking you, what is the network ID? And you're typing in the chat what you think the network ID is. All right, so I'm seeing the responses. Please remember to keep your mics on mute. All right, so most people get it right. And the answer is the network address is 192.175. How did we come across that? Or how did we come up with that? Simple. We look at where the 255s are positioned in relationship to the IP address. So under 192, we'd have 255. That means that 192 is going to form a part of the network address. And under the 175, we have 255. So that also means that the 175 forms a part of the network address. Under 26, we have 0, and under 19, we have 0. So it means that those are going to be the host portion of the IP address. So the network address is 192.175 for that example. Right, so I hope you're good. If you're not good, let me know. But we're not going to spend a whole lot of time on this because this is not the major thing that we want to look at this evening.
Can you repeat what you said about 26 and 19?
Those are the host values. An IP address gives you 2 pieces of information. It gives you the network address and it gives you the host number. So the part that says 0 will tell us that that's the host number. All right, great. I'm seeing a message in the chat. Let me address that message. Most of the classes are not going to be recorded. Yeah, so you need to show up to class and you need to participate in whatever activity. So just consider this a face-to-face class. So most of these are not going to be recorded. The only reason why I'm recording this evening is because the videos that you were supposed to watch in preparation for our discussion this evening, some of you would not have found it because I did not add it to the playlist as we saw earlier. So what I'm doing is I'm giving you the opportunity to watch so that we can come back next week and discuss. So I am pre-recording videos and I am uploading them to the playlist each week so that you can watch ahead of the class, and then we'll come back to the class and we discuss and we do activity. Yeah, so we're not recording these sessions apart from this one. Or if I think it might be fruitful in terms of the demonstration to record, but don't expect that we're just going to record all of them. No, you need to turn up the class and you need to pay attention and participate. So think of this as a face-to-face session. All right. So, all right, so I don't have seen any more, so let's move on. All right, so that out of the way, we were looking at the fact that we had configured the IP address on H1, and we also need to configure the IP address on H2. So H2, go to the desktop, go to IP configuration, and type, based on what we have on the information we have on the diagram, type the IP address is that I'm going to place on H2. All right, so I see some persons out of the gate early. So it's 192.168.20.2. Great. So we now have the two devices. They are connected physically, and we have also placed the IP addresses on them. Now the IP addresses are actually found at layer 3. So it's a layer 3 that deals with IP addresses. So we have just completed some work at layer 1, which is the physical layer. And we have also just completed some work at layer 3, which is the network layer. And yes, you're going to go back and watch the video. There's a video there on the OSI model that talks about the different layers and the key things that occur at each of these layers. Now I need to be able to communicate. So what I'm going to do, message from H1, trying to connect to H2. So we open up H1, we go to the desktop, and we open the command prompt. And we are going to issue a ping command. Now ping expects an IP address. And this IP address is the destination. So this is the machine that we want to communicate with. So which machine we want to communicate with? Somebody just unmute, please, and tell me what I'm going to type here. I'm on H1. What IP address am I going to ping?
Is it the IP address of computer 2 of H2?
Tell me what it is.
Should be 192.168.20.2.
All right. So let's try that. And let's see if we get any positive response. So we ping the machine. We are getting some replies. And it says here that we sent 4 packets. We received 4 packets. So there was no loss. So everything that we sent, we received. So these 2 machines are able to communicate with each other. And that's good. Any questions on this point? Wonderful. So we are now network geniuses. Now we know how to connect up the devices and how to configure them so that they are able to communicate. So we just did that. Wonderful. There are some things that are happening though in the background that we kind of want to have a look at. So let's examine that now. I'm going to go to the switch. And there's a section of the switch that says CLI. That is the command line interface. It's almost like the command line that we just use in Windows. Just that this allows us to control the switch. And press enter 1 or 2 times until you see in this prompt here that says switch. And what I'm going to do, I'm going to execute a command called show MAC address table. So it's this command that you see right here. I'm going to hit enter. And what you're seeing here is that there's some information that the switch has. Let's interpret what it is saying. It is saying that on port 1, there is a NIC that has the MAC address starting with 0007. And it's also saying that on 2, that is port 2, there is a device that has a MAC address starting with 00D0. That's what it is saying. Are we clear so far?
Yes, sir.
All right,
Yes, sir.
wonderful. Good. Now the question is, how did the switch know this? That's an important question. How did the switch get this information? And secondly, is this information correct? So just jot down 2 numbers for me, please. We don't have to have the entire number. You can just have the first part, seeing that they are different. So for port 1, just type down 0007. And for port 2, just type down 00D0. Just write it somewhere so that you have it for your reference point. And this is the last thing that I'm going to do in this regard because we're pretty much out of time. So I suspect that you have that. So I'm going to go back to H1. And I'm going to issue back the IP config. But this time I'm going to use the /all option. The IP config with the /all option. And I'm going to hit enter. And right here where it says physical address, notice that there is an address here starting with 0007. Does that match back to what you saw earlier?
Yes, sir.
Good.
Yes.
So this physical address is the MAC address. This is the address that is burnt into or built into the NIC. So if we were to change out the NIC for this machine, then it means that the physical address, the MAC address, would also change. And if we do the same thing or a similar thing with H2, then we're going to say that the physical address is going to be 00D0. So let's try that quickly. All right, so we're over here. We want to do ipconfig/all. I'll look at the physical address, and right there it is, 00D0.
The only inconsistency is that is a capital D on that one.
That
On
don't
the
matter.
terminal it was a okay.
That don't matter. It's hexadecimal. So a D is a D. Right?
Right.
Yeah. All right, let's quickly go back to the switch. Here. Enable first. Here. All right, so what I've just done, I've gone into an elevated mode by typing enable, and I've issued a command that says clear MAC address table. And then we are now going to show the content of the MAC address table. So remember, you saw some data before, right? And I clear it. I'm going to now display. And now you're seeing that there's no information in the MAC address of the switch, in the MAC address table. Correct, folks?
Correct.
All right, good. Now, this is how your switch come by default, because there's no way it can know beforehand what kind of devices we are going to connect to it. All right? So we see that it's clear. I'm going to go back to H1. I'm going to ping H2 again. So we had ping, hold on, I think maybe we can find it. So I found the command, it was there already. So I just use the up arrow or the down arrow to toggle through previous commands and so on. I'm going to ping back H2. So ping H2, we're getting some responses as we had obtained the first time. And now I'm going back to the switch. And I'm going to show the MAC address table. And you see now that the MAC address table is populated. Notice also it says the type is dynamic. So what happens is each time we do some transmission over the network, then the switch is going to self-configure itself, or it's going to learn. And it's going to learn which MAC address is connected to which port. And this is how the switch is now able to transmit a packet from one device directly to another device, which is connected to the switch. In particular, if we had 10 devices on this switch, because the switch would learn the MAC addresses and which ports these MAC addresses are attached to, then when we send a packet from H1 to say H7, then it will send it directly to H7 because it would know, based on the MAC address, which port H7 would live on. All right, so that's it for us. I say one hand, I take that question, and then we terminate the session. Go ahead,
Right,
Javi.
so, let's say there wasn't any activity on the server, right? You just connected, say, 5 devices. Would the switch auto-configure itself by you just connecting them, or does there have to be activity for it to auto-config?
There has to be activity. There's no way it can learn without the activity. Remember,
Okay, understood.
The NIC has the MAC address, right? And we said earlier that we can swap out the NIC. We can change the NIC. So it means that there has to be some activity. So a packet has to be sent.
Yes, sir.
All right, cool, cool. All right, so I think that's us then, ladies and gentlemen.
Sir,
Yes, sir.
is this the first class? Because I feel like I'm a bit behind.
No, this is not the first class, but all the recordings are there for you to watch.
Okay, so this would be under which units or
What no, you know watch none yet, so you need to watch all of them.
okay.
Yeah, man. So watch from 1 to 4. Maybe by
Okay.
tomorrow you have 5. Maybe by the day after you have 6. So the point I'm making is just watch the videos in the order in which you would see them there in the playlist. I try and label them properly. Yeah, and they should be good to go.
Okay, sir.
Yeah, man, cool. And that goes for everybody. You need to watch the videos. Watch them in the order in which they have been presented, and they should be good. Go ahead, Scott.
Sir, I know you said there was no tutorial sessions last week, but I'm supposed to have my tutorial with Mr. Dana tomorrow, but I'm not seeing a link for his class or anything like that on Moodle. I don't know if you have like an email for him or if you could message him to ask him to post it or something.
Well, he knows that he's supposed to post it, so I'm assuming that he will do that tomorrow or later tonight. But I still send a message to him just to remind him. Are you sure it's not there?
I was looking, sir, but I don't see it.
All right. So I'll message him.
All right, thank you, sir.
Yeah, cool. All right then, folks. So I trust that you learned something this evening. All who learned something, type one in the chat. This is great, man. If we continue like this, we're all going to get some A's. All right then, folks. Take care. And remember to look out for the recordings and to watch them ahead of time so we can discuss, and run through examples with some understanding behind our belt so we can go quicker and cover more stuff. All right, take care.
Bye, sir.
Yeah, man. Bless.
Yeah, go for it.